So we are doing worksheet 5A now. This is relative compression testing. So what the heck is that? We're going to do a compression test on this engine without touching a spark plug. As you know, with a conventional compression test, I have to remove the spark plugs, put a pressure gauge in, crank each cylinder individually, and we do, comparison of the cylinders when we do a regular compression test. I'm going to do a compression test right from the battery negative cable using an inductive amp clamp. So your sheet here, I'll show you the setup in a moment. You're going to fill this portion out. At the bottom here, you're going to draw the diagram you see on the scope. Now, the first one we're going to do on a known good engine. So we're just going to do it the way the vehicle sits right now. Then we're going to do it with a faulty cylinder. So I'm going to cause one of these cylinders to have low compression. You're going to see which one that is, but we're not going to know which one that is. We're just going to see a bad cylinder. Then we're going to sync our signal with number one cylinder, and you're going to tell me on this lab sheet which cylinder has the misfire. And at the bottom, we're also going to calibrate whether or not this vehicle is in time. And we can use this test that we're going to do to verify whether or not our valve timing is correct and our ignition timing. So we're going to be able to see if we have a jumped timing belt or chain using this test without taking anything apart. And that is one of the beautiful things of this test. We can do non-intrusive testing and verify something that years ago would have taken hours to do and lots of work. Okay, so the lab scope, like I've said in previous videos and in theory class, is probably one of the most powerful diagnostic tools you will have access to. Okay, so the first thing we're going to do is our known good engine. So we will look at our setup here. So I've got my high amperage amp clamp. So this is a little different from the one we were using before. This is upwards of 600 amps. And we're going to put it around our negative battery cable right here. And that's it. That is really my only hookup to the vehicle right now. Okay, and all I'm going to do is come over to my scope, and I am going to tell the scope that I'm using the 600 amp clamp, which we can see here. Right, if I scroll down into this drop-down menu, I see all of my different options, and we're right here with our 600 amp clamp. Okay, the other thing I need to do is set my scale. So because we're looking at starter draw, and we know that starter draw for a four-cylinder engine should be around 100 amps, I am on the plus or minus 200 amp scale. It's going to be slightly over 100, so if I only go to 100, it's going to go off the screen. We want to keep it on the screen, so we're going to set it to the 200 amp scale. Okay, after I have done that, that is really all we need to do. So I'll keep you focused on the screen here, and I will go and crank this engine over. I've also had to disable the fuel system, and I did that by removing the fuel pump relay. So we can see here in the relay box, I have the relay out, and it would go into this cavity right here. Okay, so I'm going to crank the engine while we're observing the screen of the scope. And then we're stopped, and now I will stop our screen, and I can scroll back through previous screens. So there we go. So right now we are looking at the peaks of starter amperage with each cylinder on its compression stroke. Okay, and I can actually scroll back another screen. We can just see here our rush-in current where we've started to turn over this engine from static. Unfortunately, I would have hoped to have captured it over here, but that's all right. This is what we're really looking for. So this is our settled starter amperage. So we can see our amperage right here. We're at 139 amps. It's pretty level all the way across, which is what we're looking for. Okay, if I bring this cursor down, and put it across the tops, we can see that we are pretty much level for all of our cylinders. So what are we looking for when we do this? We're looking for an obvious cylinder that's lower than the others, or possibly even missing. Okay, so each one of these cylinders is on its compression stroke. Of course, starter amperage is going to increase when we have more effort to rotate the crankshaft, and we're going to have maximum effort to rotate the crankshaft with each cylinder on its compression stroke. Of course, both our valves are closed and we're compressing the air and fuel mixture into the cylinder. Okay, so I'm going to cause a problem now with this engine, and we're going to see what that looks like. Alright, so we're just going to continue filming here. I'm going to move this cursor back up to out of the way, and I'm going to go and cause a problem with this cylinder, or this engine. So this is a really valuable diagnosis. And this is the test that I used when I found the problem with my cylinder head on my Honda last summer. So this is a really valuable diagnostic test that we're doing here. So this is really quick. I'll have this ready in a second and we'll repeat this test and you can see the difference. Okay, so now I'm going to go and crank the engine again. Perhaps I'll ask my camera person to tell me when it's right there so I can get the entire capture. Okay. Just hold your hand up and tell me when to crank. Okay, you can also, while I'm doing that, hear the change in cadence of the engine when it rotates. Okay, there's a definite audible change when I have a cylinder with low compression. So I'm going to scroll back through now my screens. There we go. So obviously now we have a problem right here. This cylinder, whichever one it happens to be, is missing compression. So I'll bring our cursor back down, line it up across all of our cylinders, and we can see we have a missing cylinder. Okay, now we don't know what cylinder that is. Okay, when we're looking at this, and if this is a V6 or a V8, obviously we're going to have a larger gap between them, but it's going to be even more difficult to tell based on, just looking at this pattern. All I know is I have one cylinder that's low. If this vehicle came in with a misfire, and this is one of the first tests that I do every single time, and the reason I do it is because of its simplicity. Right, I have one tool connected to the negative cable, my scope set up, and I do my crank. When I'm doing drivability in the shop, this scope is set up all day long. This is one of the first things I do when I come in the morning, is I get this set up, because this is what I do all day long. So it's not a chore. It's not like I have to go dig my scope out and get it all set up and take a lot of time. I'm ready to go. All I need to do is take my amp clamp, put it around that cable, calibrate the scope, and I do the test. It's very, very quick and it's very, very simple. Okay, so how am I going to verify which cylinder this is? Well, what I'm going to do, I'm going to remove this cursor back out of our way, and I'm going to make this live again. And now what I'm going to do